Okay, so we are back with setting up our RhinoCAM machine operations, and last we left off, we are starting to set up a two-axis profiling. So I'm going to first change my view to the top view so I can look down on everything. It's just going to make things easier. And the first option that this is asking me is, what are my part regions? What am I cutting here? And this is where order of operations are important. We want to work from the outside or the inside out. We want to do small things first. So I'm going to come down here to select curves and regions, and I'm going to select the interior cuts, which are these holes. And there's not a whole lot. Here, here, and here, and I'm going to hit enter. And now I'm back, and these are the drive regions. All right, I'm going to come over to Tool, and one thing I don't see on here is a 1/4 inch tool for cardboard. So what I'm going to do is I'm going to select a 1/4 inch upcut for wood here, and I'm going to edit, create, select tool. And essentially the measurements are all the same. I'm going to change wood to cardboard. And then I'm going to come to find my feeds and speeds. Now, the measurements are all the same, but what's going to change is the feeds, or how fast this cutting tool is going to move through the material. And we discussed this in lecture before, but this is important because different materials are denser and require you to go maybe slower or faster depending on if that is a really high density or a really low density. It also depends on how many cutting edges there are and things like that. So let's go to load from file, and this is going to come up, and we're going to have a lot of different options. Now, stock material, there isn't cardboard on here. We're just going to stick with wood as a rough estimate. Surface speed is 1600 is a good rule of thumb. And I'm going to say we have 2 flutes. Our tool diameter is 1/4 inch. Now our max spindle speed is only going to be 18,000. And you can see here it's kind of maxing out. And when we change some of these things, it's going to automatically calculate a feed rate for us. Now, max feed rate, probably we're going to stay below 200 just to be safe. And what we're going to do is we're going to, well, probably more like 300. Cardboard is pretty thin, so what we can do is we can change our feed tooth rate, which you can find on the tooling, or you can look up exactly what these specific numbers are. You know, people have already calculated these things to help you determine what this is, and you just have to go do some sleuthing. So we've got 0.005, which is about 180 inches per minute. You know, I'm going to bump that up a little bit for cardboard, 0.006, which is about 216 inches per minute. Just a little quicker, especially because, you know, we might be doing some thinner stuff. So I'm going to hit OK, and I'm going to save edits to tool, edit existing tool. So now I've got a cardboard option. What I should have done was save as new tool, but this cardboard 1/4 inch upcut bit will be available for you as well. I'm actually going to hit OK for now, and then I'm going to come over to my feeds and speeds, and I can hit load from tool. I don't have to re-input those. As long as I have that same tool, I can just reinitiate these feed rates and things. So I'm going to hit load from tool, which is already on there, which is great. I'm going to come over to clearance plane, and this is how high the machine is going to move when it's not cutting. So when it goes to a new cut, I'm going to say stock max Z, and I'm going to say that that is 0.5. Sorting, I'm going to do minimal distance sorting so that the algorithm can automatically figure out the best path to go down. I'm going to come to advanced cut parameters. I'm going to turn off arc fitting. And then I'm going to come down here to bridges and tabs. Now, tabs and bridges are things that help keep the piece the interior object that's going to get kind of cut out, it's going to keep it in place from flying away. Now that's very important for when we're cutting denser materials like wood. We don't want parts flying off at us. But here specifically, it's just a good thing, good practice to have, even if it is a light material. I'm going to turn on rectangle, and this little pop-up block is kind of showing you what it's going to do, and we'll take a look in a second. So I'm going to select rectangle. Bridge height is going to be the 0.26, the thickness of our material, and the length is going to be 0.25. And number of bridges is, for this, we only need one. It's going to do one bridge. And I'm going to go to my entry and exit tab next. Now this is how the tooling is going to enter the material when it's cutting. How's it going to start? And for the entry motion, we're going to do a long path. And that's important because the tool is going to come down and move over and down diagonally into the material. It's following this path essentially. And the reason it's following that path is because a cutting tool might not have a cutting edge on its bottom. So it can't plunge directly into the material like this path would do. It's going to hover above it and move diagonally into it from the Z height. And that's going to allow a clean cut, and it's not going to burn the material. It's not going to damage the cutting tool. For exit motion, we're just going to hit none. It's just going to move up and move to the next cut. Now, cut levels. This is very important because we're referencing our geometry in different locations. We're going to say our geometry is at the bottom, right? Because everything on here is flush with the coordinate plane. If we were to look at this from the front view, everything's flat. If we were to zoom in, it's flat. And we are also referencing everything to the bottom of our stock, or the bottom, or the bed of the CNC machine. That way, when we're cutting, we're not going to go into the table. So what we're going to do next is we're going to say, what is our total cut depth? And the total cut depth is the thickness of our material, which is 0.26. Now our rough depth is going to be 0.26. You have an option for a finish cut, which maybe you want it to be a little thinner. So you could say 0.25 and this is 0.99999. We're going to just stick with 0.26, just a rough cut, completely rough cut. Okay? And what we're going to do here is we're going to change that to 0.26, rough depth per cut. So depending on the size of your tooling or the diameter of your cutting bit, that will change how deep you can go per cut. All right. So for example, if I was using an 1/8" diameter cutting bit, I could only go, the maximum depth I could go is the diameter of that cutting bit. And I'd have to make 2 passes, 0.13. Thankfully, we're using a 1/4" bit, so we can go a full cut at once. So I'm going to do 0.26. All right. Now, this is great. So again, total cut depth is the thickness of the material. We're only going to do rough cuts, and the rough depth per cut is going to be the diameter of your tooling. Cut parameters. This is going to describe where is this cutting along this line. How is it going to cut along this line? Cut direction, mixed is fine for right now. And what's important here is we're going to use outside, inside for closed curves. What that means is the tooling, the router bit, is going to cut either on the inside or on the outside of this line. And because this is an interior cut, we want this line to be perfect. And so the cutting tool has to be on the inside, right? Because the outside of this is our seat cover, or which one is it? It is our seat. So then I'm done. I'm good to go. I can hit generate, and it's going to generate these tool paths. And you can see the blue here is the path that the router bit is going to follow. I'm going to look at this in perspective mode. And what I can see here is the bit is going to come, it's going to move down, and it's going to move diagonally into the cut. And then it's going to move around, it's going to move back up and over. This is the bridge. This is this sort of tab that's going to be created to keep this piece from flying away. All right? And it's going to do that for all of these pieces. All right, cool. So now what we can do is we can set up the next cut, which is going to be another profile cut, but for our exterior pieces. And we're also going to set up an engraving option so that we can cut these in. So again, we're going to work from the outside in, and next we're going to work on our exterior cuts. All right, so we'll see that. We'll do that in the next video.